mytester.co.uk.
Hello YouTubers, and welcome to the next in the series on how to solar power your home. Now in this video what we're going to cover off is all things solar panels. So we're going to have a look at the different solar panel types, the ratings on them, the different quality issues you need to be aware of. Should I go for an amorphous solar panel or a monocrystalline or polycrystalline? We're going to cover all of that off, and then to end off I'm going to talk about solar power installers and what you should be aware of in choosing a solar panel installer. Right, so let's kick off with the different types of solar panels. So as I showed you over here, this is an amorphous panel. Now they're very easy to recognize because you don't see the different separate cells as you would on a monocrystalline or a polycrystalline. These panels, generally speaking, their efficiency is a lot lower. It's often half that of a monocrystalline or a polycrystalline. Now on the monocrystalline panels tend to lead the efficiency numbers, and the polycrystalline panels follow close behind. But now let me just talk about and cover off all the information on these amorphous panels. Now there's a few important facts to dispel, which if you go and read what manufacturers say about amorphous panels can be very misleading. They'll either say the one common misnomer, which I particularly went and bought these because I thought I had to check the claim myself, is that they say they perform well under low light conditions. Now that is a total false statement. What they probably mean to say is they perform well under shaded conditions, and in fact what they should be saying is that they perform well under partial shaded conditions. Now if they said partial shaded conditions, they would be spot on. If you have partial shading on any solar panel, in particular a mono or a polycrystalline panel, if you just cover up a few of those cells, you almost lose all the power on your panel. Whereas on an amorphous panel, if you only partially cover the cell, whatever percentage you cover, that is roughly the percentage of power you'll lose. So you only lose the power from the area that's covered, because it hasn't got individual cells which are linked together, and therefore if you partially cover one cell, it cuts the power going to all of them. You can in the monos and the polys get bypass diodes, but nonetheless you are going to lose power. But now the question is, why on earth would you install a solar panel where it's going to be partially shaded? You don't want to do that. That would be a no-no, because you want your solar panel to be out in the sun. So let's talk about that fact where we talk about low light performance. From all my testing across several manufacturers' panels and comparing monocrystalline to polycrystalline, low light performance is the best on a monocrystalline panel. So certainly do not be fooled by what manufacturers say on these panels for that reason. Now generally speaking, you will need double the size panel to get the same wattage on an amorphous. So you're going to lose a lot of roof space. Also they're often double the weight, and the reason for that is that they have to, on the thin film, these thin film panels have to be sandwiched typically between two pieces of glass or two thick substrates to keep it safe, and that often doubles the weight. And that means handling them is a problem. They are very heavy, and the mounting costs are going to be more because you have to have far sturdier mountings for your amorphous panels. The only area that I'd say that they have an advantage is apparently, and from a little bit of my testing, they do perform well better under heat. If there's high heat, particularly if you've got them placed on black shingles, so you've got a lot of heat coming from the shingles in sunlight, then they do have an edge over the other technologies, but not much. They do also perform well under artificial light. And to give you an example, you will note that wristwatches and solar powered calculators, the little solar panel that's on a solar powered calculator, that will be an amorphous solar panel. Why? Because it reacts better to the wavelength of light from artificial light sources, and hence that's why they use it in these kind of applications. Are you going to power your home with artificial light? No, you're going to use the sun. So I would say steer clear of amorphous panels, because also the technology is not that old. So whereas manufacturers of monocrystalline and polycrystalline can give a 20-25 year guarantee, these haven't been in the market that long to really warrant that. And also apparently the performance of the actual panel degrades very quickly in the first few months before it settles. So often a good manufacturer of these would have to oversize them. So the only other real benefit to amorphous or thin film technology is perhaps when it's not mounted in a rigid panel, but in a flexible film, which maybe you may be able to apply to some unusual places that you wouldn't be able to install a firm fixed frame panel. That to me is its perhaps only advantage, but otherwise I would steer clear. Right, so let's take a look at monocrystalline versus polycrystalline. Now over here I've got two panels, one down here and one up here. The one down below is a polycrystalline, and normally the polycrystallines can be recognized because the actual cells are cut very square because they're manufactured. So they can, in the die, they can actually cut them very square and pack them very tightly together. The monos typically, because they're made out of a single cell of silicon, they have to be cut in a very specific way. So you'll often notice you have beveled edges, and that means that often the spacing between them in a panel cannot be done as tightly as a multicrystalline. So in theory, even though a monocrystalline is more efficient and therefore the size of the panel should be smaller, often you'll find that a polycrystalline panel, they are virtually the same size, or you may find in fact that the polycrystalline panel might be slightly smaller because of the way they can actually pack it in. Now there's only a small difference there, so I wouldn't judge a panel too much by that. Probably the most important thing to note here is in terms of heat and light performance, the monocrystalline tends to do better. At the beginning of the day when the sun is just coming up and you haven't got a lot of light falling onto your panel, you will generally find that the monocrystallines tend to start generating more power sooner and will be able to generate a bit more power towards the end of the day. They also have better tolerance to heat than the polycrystallines. So which one should you go for? Now sometimes for one you don't have a choice. You may find that your supplier is either out of stock, or they just the certain size panel, wattage of panel that you want, they just don't have in stock in either a mono or a poly. There you need to let a few other factors be your guide, and we're going to talk about the other factors now. But in terms of quality, safety rating, the brand, if it's a name brand and is a well-respected brand, and then obviously getting down to your price per watt. Ultimately, if you can get, let's say there's a more than 10% difference in the price per watt, if you can get a polycrystalline that is 10% less per watt than a monocrystalline, then that may be your guide, as long as you know the quality and the brand are with you. But otherwise, if you do have a choice and there's not a huge price difference, and the quality and the name brand is good, I would go for a mono if you do have the choice. Right, so the next thing to talk about is the nameplate power rating on your solar panel. Now obviously at the moment the majority of solar panels are produce DC current. Soon there are going to be solar panels which have mini inverters built into them, and they'll produce AC current, and that is something I'll look at in the future. But on that nameplate, let's say you go and purchase a solar panel that says it is rated for 250 watts. That, generally speaking, is an STC rating, a standard test conditions rating. Now you may also come across another rating called PTC, which is more PV testing conditions. Now the PTC testing is done under more real-world conditions. The standard test conditions are done under very artificial environment where the rating, they flash it with a light under a relatively low ambient temperature, so it doesn't give a real world power rating. Whereas the PTC, it is done under more real world testing conditions, but it's still not true real world conditions, so don't expect to exactly get that rating out of your panel. Another important fact to note is that often manufacturers will give a tolerance rating on that. What they'll do during the manufacture process, they don't know the exact power rating that a solar panel is going to produce until they've put it all together. They may have a rough idea of what all the individual cells are going to do linked up together, but until they get them all linked up together, sandwiched with the glass on top, with the panels all put together, they don't know exactly what it's going to produce. So they'll then do the test to make sure it's within that kind of, let's say we've got a 250 watt panel, that it falls roughly within that 250 watts. Now the cheaper solar panels and perhaps the not so good manufacturers will actually give potentially a negative rating. They may say that even though it says 250 watts on the panel, there might be a negative tolerance of, let's say, up to 10%. So that means you may lose 25 watts because they're allowing that negative tolerance. A good manufacturer will actually state on the panel itself that it's a 0 or +5 or even +10% rating, so that if they get any panels that fall below their nameplate value under their test conditions, they won't pass it. So that is something else to certainly keep an eye open for. Right, so next we want to start talking about the quality and ratings of solar panels. Now, I've had a few solar panels pass through my hands, so I've been able to get a better understanding of some of the build quality and some of the issues you can come up against. Now, this solar panel that I have in my hand is produced by a company called Set Solar. Now, I went and bought quite a few bits and pieces from Set Solar. When I say manufacture, they basically get the silicon wafers from overseas, but they assemble the frames and the backing and everything else here in South Africa. Now, on the nameplate, which I'm going to do an insert on so that you can see, if you look closely, it provides you with the nameplate rating. It happens to be 55 watt peak. It gives you the kind of maximum voltage rating and the current rating. And it also gives you the standard test conditions. It notes what those test conditions are, which for STC are standard. But nowhere on that nameplate does it give any kind of quality or safety rating, either a UL or a CE, that it lives up to some kind of standard. And that should be your first warning that something is awry. Now, all of this I'm talking about is if you're someone who's just building a small project, or you a DIY person and you're just experimenting, perhaps the quality and longevity of a panel isn't an issue. But if you are going to be installing a solar array on your house, 2,000, 4,000, 5,000 watts of solar panels, it's going to be a huge cash outlay. You want to know that that investment is going to work for 15, 20, 25 years. Because you're potentially only going to see a return on your investment in anything from 7 to 15 years. So if those panels are only going to last for 5 years, you're going to be in trouble. So these are the things to look out for. For one, often manufacturers, you can get what are classed as A-class panels, B-class panels, and C-class panels. Now the A-class panels are the panels which are 100%. They've passed good inspection and they go for the full retail price. The B-class panels, it's been noted that there is some visible discrepancy either in the glass or some occlusion on the panel, but it doesn't affect its performance. Those panels, generally speaking, sell for slightly less, but in theory they still often will give you the full warranty on those. Then you get the C-class panels, and those often will have some visible defect on the panel, but it does slightly affect the performance of the panel. And normally they'll say it drops the performance of the panel by 5 or 10% or something like that. But normally they sell at really good prices, and it might be very tempting to go for that kind of panel. However, generally speaking, they'll only give you a 2 to 5 year guarantee on that kind of panel. And again, that should be your warning. If you go buy an expensive array and suddenly the performance drops by 30-40% after 5 years because of some defect on it, you're going to be very sorry. So certainly do be aware of that. Right, the next thing we want to have a look at is build quality. And again, certainly when I started purchasing solar panels, I wasn't aware of all the little nitty bits and pieces, but there's certainly some things you do need to be aware of. Now again, the two panels I'm going to show you, or the few panels I'm going to show you, are they either cheaper Chinese or I said the set solar panel. I'm going to start off with the set solar panel over here. Now the first thing I want to show you is that you'll notice it's got a black frame versus the aluminium frame of the other two solar panels here. So this black frame is obviously a mild steel which has been powder coated. Now the problem with that is if you get any chip or nick on this powder coating, you're going to get corrosion of the frame. If that starts corroding, you're going to get moisture into your panel, and there you go. It's not going to work very well. Another issue I want to highlight, I had this on my roof as a test, and as you can see they've got screws which hold the panel, the actual frame together of the solar panel. And what do you note about those screws? They're already corroded. They didn't even use stainless steel screws to screw the frame together, so that within less than a year these screws have already started corroded, which again means you're potentially going to have gaps opening up and moisture getting into your solar panel, which as soon as you get moisture into the solar panel over here, that's it. You're going to start losing performance and you're going to write it off. Another point to note about these solar panels, potentially when you're going to link them up into, let's say, an MPPT grid tie inverter, you're going to be stringing potentially multiple panels together and you're going to have a high voltage going through these solar panels. Now the problem is that once you start having a high voltage going through your solar panels, and you have to check that your solar panels are rated to be able to do that, you then have the risk of things arcing over if there are metal connections that are too close to each other. So if we go and have a look, these metal tabs over here are the flat metal tabs which link the actual silicon cells together. So they run as ribbons right through the solar panel, linking all the cells together. But as you can see, where they come up to the frame, there's not much gap between the frame, and if you have a high voltage going through these, you've got a potential problem. Now this panel is a 55 watt panel, so you wouldn't think that you'd have these in a large array on your roof. But it's something to look out for. If you have a 250 watt panel where this gap is small, that is a potential no-no. And I'll show you on this panel over here. This is a bigger panel, and as you can see, right, the gap, there's not much gap between the actual frame and that tab itself. What you want to be looking for is more like on this solar panel over here, where you've got a little bit of a margin so that if you do have any high voltages flowing through your panel, there's no risk of arc over and thus the panel not performing as it should. Right, and then probably a last but also a very important thing to note about solar panels and what some manufacturers do. If you can see this solar panel at the back here, and you see the solar panel sitting in front of it over here. Now these are both 55 watt panels. The one is obviously polycrystalline and the other one is mono. Now as I said, obviously there is an efficiency difference. And potentially if you have two 55 watt panels, one being mono, one being poly, the mono might be slightly bigger because of the die for the silicon can't be cut as tightly. But as you can see, there's a big difference between the two. One would almost expect that panel behind to be at least a 60 watt, but it's not. It's 55, and so is this one. So why is there a difference in the physical size? Now as it turns out, and I discovered this by mistake because I was concerned about the performance of this 55 watt panel from Set Solar. When you go and look at their spec sheets for a 45 watt, a 50 watt and a 55 watt panel, the physical dimensions of the panels were all the same. But how can that be? Well, remember I told you about that testing, that standard testing, and basically that some manufacturers will have a tolerance. Well, what Set Solar do is they are manufacturing in the hopes that the panel of a certain physical size and with the number of cells is going to produce 55 watts. But when they do their testing, if it falls short of that 55 watts, all they do is see what it produced, and as long as, let's say, it's around 50 watts, they'll then just put a name sticker on it of 50 watts. And if it falls below the 50 watts, what they'll do is take that same physical frame, but just put a 45 watt sticker on it. So you may think that obviously you may have a rough idea of the size, the area that you're going to use with, let's say, 250 watt panels. But if a manufacturer is playing that game of, let's say, an underperforming panel, he merely puts another wattage rating on it, but yet it's the same physical size as a 250 watt, that may catch you in terms of the size on your roof. Or certainly for a project, let's say you're building a project where you've specified, you understand a certain size of a panel, you go to your manufacturer and suddenly the physical size just doesn't seem to match up with the wattage. So that's certainly something to be wary of. I certainly think it's a very bad practice by manufacturers. They should at least highlight that when you're purchasing from them. Right, so another question that people ask, what about DIY or solar panels that you produce yourself? Because there are lots of adverts on the internet and on YouTube touting these books that give you guidelines on how to produce your own solar panels for ridiculously cheap costs. Now, hopefully, now that you've seen some of the pitfalls with solar panels that are produced by so-called actual manufacturers who have the proper equipment and skills, you can see what can go wrong. For one, I would say if you are a DIY person who just wants to do this for fun, for a small little project, go ahead and do it. If you are planning to produce little solar panels to power your home or your RV or something relatively critical where you want longevity, I'd say beware of the following. For one, you need to find good quality silicon wafers. Two, you need the skills to be able to connect and solder up with that flat tape all those little silicon wafers together. And then three, there's the expense of the aluminium frames, the C-section frame around the side, and if your solar panel is going to perform properly, you need very expensive glass, tempered glass that goes in the front. And it's not just tempered glass, it has to be non-reflective glass, or otherwise it's going to reflect a lot of the light and reduce the performance of the solar panel. Now, if you haven't done this before, it takes time and there's going to be a fair amount of wastage just learning how to get one or two right. And if you go and see YouTube, there are loads of people who talk about, yes, they did it thinking it would save them money, and often you'll note in the video it says failed. That there are some honest people who go through the difficulties and the failures. If you manage to come across someone who's managed to produce these panels that cost significantly less than a manufacturer produces them, and he's had them installed for 2 to 5 years and they're still doing well and moisture hasn't got into them, then go and follow that. But I'd say for the most part you're taking a risk, and I'd still go out and look for a good manufacturer who produces a good quality panel. Right, so before we talk about the installers, just to summarize up about these solar panels. There's obviously a lot of information to take in there, and it's perhaps not going to be easy for you to go and check all those things if you're the end user trying to purchase solar panels for your house. So the best thing I can advise is to go and do whatever solar panel you choose. Is it a name brand which has been around for at least 10-15 years? Google it. Google the actual model of the solar panel that you're considering to install. Find out if other people have bad things to say about it. Find out if it has been used in relatively big projects. As I say, you are going to pay a little bit more potentially for those name brand modules, but I think in the long run it'll pay off. As I said, if you're someone just doing a small little project or experimenting like I sometimes do, then that potentially doesn't matter. If the solar panel doesn't work after 2 to 3 years or the performance dips off, it's not a big issue. But if you've made a big investment for your roof space on your house, then that potentially is going to hurt you in the long run. So do take that in mind. Right, so the next thing I do want to pick up on is solar panel installers or solar system installers. I have seen the kind of workmanship here in South Africa, and it can be a mixed bag. I think there are some very good solar panel installers, and there are some really fly-by-night people. And there's certainly, I would say, if you are looking to have an installer do your system, there are a few things you need to note. For one, don't just base your selection purely on price. The cheap fly-by-night people, because they don't have many overheads or they haven't been in the industry for a long time, can probably get away with doing a solar installation on the cheap. Find out if there are any particular quirks about your installation, i.e. are you a grid-tied solar installation where perhaps you need to comply with certain regulations of your power company or your local governance or municipality. Is your solar installer aware of that, and has he done work like that before? 2, when it comes to the electrical work, does he have qualified electricians who know both the AC side when they tie it into your house and the DC side? Do they know how to run and size DC cables properly? Do they know how to install a battery bank properly and size the cables and connect the battery bank up so it works efficiently? If they don't, you can potentially have certain batteries or cells in your battery bank not being utilized properly, and your battery bank could be written off in a far shorter space of time, and that could be a huge investment. Once you think you found the right installer, ask him for at least 3 references. Say, I would like to go and see someone that you've installed within the last 6 months, and you need to be able to call and speak to that person and ask them whether they've been happy and whether their solar power installation is working fine. Ideally, it'd be nice to be able to go and see the installation yourself, but they might not be nearby. You then would like to see a solar power system that was at least a year or 2 old, and then I'd say you'd want an installation that's at least 3 to 5 years old. You want to go phone someone who's had their installation done 3 to 5 years previously and know it's still performing correctly, that they've been able to get backup support if required from that installer. There are many folk who haven't been in the industry that long, and fair enough, people have to cut their teeth and learn along the way. But ideally, you don't want a new installer coming and cutting their teeth and learning what to do on your installation. You may choose the right equipment, the right inverters, the right batteries, the right solar panels, and if the person installing doesn't install them properly, for one, it won't perform correctly, and 2, it won't last long. So certainly do be aware of that and pick and choose very carefully. Anyway, I thank you very much for watching this video. I hope it's been of value. I'm soon going to be flying off to the States, and I'll be able to get my hands on a lot more equipment, and there we'll talk about the grid-tied solutions, and I'll be looking at the mini inverters that you can stick on the back of solar panels, and the so-called AC solar panels, the plug-and-play solar panels. So certainly do subscribe if you haven't yet subscribed, and do give it a thumbs up if you do enjoy the content. Thanks very much, and I'll catch you soon for the next video. Cheers.
Tester.co.uk